Hello everyone, welcome to our channel. In this video, we will continue building our database design. You'll see the complete design come together. Remember that in the previous video, we used navigation properties to link tables to one another. Then we applied database rules directly in our code using data annotations. Data annotations are a simple and straightforward way to define how the columns in our database tables behave. However, if you are working on relatively complex or large projects, it's recommended to use another tool and approach called the Fluent API. Fluent API gives you centralized and flexible control over your configuration instead of having to manage data annotations across individual models one by one. Entity Framework Core offers the Fluent API to help you easily manage your data models and the relationships between them. For large and complex projects, especially those with the potential to grow over time, the commonly preferred approach is to use navigation properties in your models and define the detailed behavior of the columns using the Fluent API. Later in this video, you'll also see that we defined the relationships between the tables using the Fluent API, in addition to defining them with the navigation properties. You might be wondering why we define the relationships in both places. First, navigation properties are necessary to navigate between related data models and to take advantage of their benefits in queries. In addition to that, managing relationships through the Fluent API helps avoid potential issues, especially in projects that rely on cross tables or need to handle composite keys. To sum up, the Fluent API offers flexible and scalable management of your database. It provides a clean and independent way to model your data, and it gives you easy access to configurations, allowing you to manage and update them all in one place when needed. Using the Fluent API and navigation properties together is a widely acknowledged best practice. It helps you configure the database schema on a solid foundation while building a robust and scalable data model. Let's get started. Open Visual Studio Code. We'll continue working on the project we created in the previous video. First, make sure that the MSSQL server is running properly in Docker. If you want to learn more about Docker and MSSQL Server, you can check out the video in the top right corner of the screen. Previously, we used Azure Data Studio to manage our database. In today's video, we will be using DBeaver instead, as it provides an easy and more effective way to view ER diagrams. And if you want to learn how to use DBeaver in detail, feel free to check out the related video linked below. Let's connect to our database using DBeaver. I'll show you the database diagram we created earlier. You can open the diagram by right-clicking the Tables section over here. Let's also check out the database design we created in DBdiagram.io from our browser. We are going to complete building the entire database based on this design using the Fluent API and navigation properties. So I'll delete the previous version to start with a clean setup. Make sure to delete the migration file as well. Open the AppDB context class. We are going to define a one-to-many relationship between the user and post tables. Remember, in our database design, a user can own multiple posts, but each post is owned by only one user. Let's define the relationship between tables using Fluent API and save it. Remember, if you don't save the changes, they won't be reflected in the migration file and therefore not in the database. So don't forget to save your changes. You can simply use Ctrl+S. Create a new migration file to apply the changes to the database. Our new migration file is ready. Now use the database update command and press enter to apply the changes to the database. As you can see, our database has been successfully created using the migration method. Let's go ahead and check our new database using DBeaver. Refresh the databases, and as you can see, the new database has been created. See that the relationship between the tables has been created. Before we continue, open the user and post classes and remove the configurations we previously made using data annotations. We'll redefine them using the Fluent API. This is the end result of the configurations we made using data annotations. After we apply the same configurations using the Fluent API, the end result will remain the same. We are only changing the method of defining them. Create a new migration file to apply the changes to the database. Then use the database update command and press enter to apply the changes to the database. As you can see, our configurations are in place just as they should be. Let's continue by creating the remaining tables in our database design. We'll start with the like table. Right-click on the Data Models folder and select New File. Name the file like.cs. We'll define fields inside the like class to represent the corresponding columns in the table. Now create the relationships between the like table and the user and post tables. A user can like multiple posts. Therefore, we'll define a one-to-many relationship to represent this. Let's hang on a second and have a look at the like table here. As you can see, like table only holds the keys from other tables. It's a cross table. We need to pay more attention to delete rule when we have cross tables. When we define a cascade delete rule on a table, deleting a record from that table will also delete all related records. By default, Entity Framework Core applies cascade delete unless you explicitly specify otherwise. However, applying cascade delete to a cross table, like our like table, can cause an error. You can use either no action or restrict as a delete behavior in this case. No action means no action will be taken on related records when a delete occurs. Restrict, on the other hand, throws an error if there are related records. You can choose the one that best fits your project's needs or requirements. In our case, we will use no action. Create a new migration file to apply the changes to the database. Then use the database update command and press enter to apply the changes to the database. Refresh the diagram to see the changes. Let's continue with the message table next. Right-click on the Data Models folder and select New File. Create the message CS. Define fields inside the message class to represent the corresponding columns in the table. Then write the restrictions to the AppDB context. The message table is also a cross table. The slight difference is that both the sender and the receiver are records from the user table. Therefore, we establish two separate relationships with the user table, one for the sender and one for the receiver. A message must have a sender, which in our case is a user, and each message can have only one sender. A user can send multiple messages. Let's go ahead and configure that relationship. You might make a few mistakes during the process, but don't worry, Entity Framework Core will warn you if something is off. Like so, we should have written message instead of user here. In our database design, a message can have only one receiver. On the other hand, a user can receive multiple messages. Let's go ahead and define this relationship as well. Create a new migration file to apply the changes to the database. Then use the database update command and press enter to apply the changes to the database. Refresh the diagram to see the changes. Let's continue with the command table. Right-click on the data model folder and select New File. Create the command CS. Define fields inside the command class to represent the corresponding columns in the table. Then write the restrictions to the AppDB context. A command can be written by one user, while a user can write multiple commands. Therefore, we'll define a one-to-many relationship to represent this scenario. A command can be written on a post, and a post can receive multiple commands. So once again, we'll use the one-to-many relationship to represent this. Apply the same relationship in the AppDB context class and make sure they define the restrictions as well. Create a new migration file to apply the changes to the database. Then use the database update command and press enter to apply the changes to the database. Refresh the diagram to see the changes. Let's continue with the follow table next. Right-click on the Data Models folder and select New File. Create the follow CS. Define fields inside the follow class to represent the corresponding columns in the table. A user can be followed by another specific user only once. At the same time, a user can be followed by many different users. Now let's create this relationship in the AppDB context class as well. A user can follow another specific user only once. At the same time, a user can follow many different users. Let's create this relationship in the AppDB context. Create a new migration file to apply the changes to the database. Then use the database update command and press enter to apply the changes to the database. Refresh the diagram to see the changes. That's it. Thank you for watching. Please don't forget to subscribe to our channel and like the video to support us.